Hello and welcome to Advanced Algebra. In this first video, I will illustrate two types of problems. The first type involves right triangle trigonometry, and the second type involves angle of depressions and angle of elevation. We will define these two types of angles. Let's begin with the first type of problems. Alright, so in question 1 and 2, I'm giving you the trigonometric value of an angle alpha, and alpha is an angle in a right triangle. I'm asking you to find the other two trigonometric value of alpha. So I want you to find the cosine of alpha and the tangent of alpha, right? And I'm also asking you to find sine square plus cosine square, okay? So after you find cosine alpha, you could find sine square alpha plus cosine square alpha. Now be careful, do not round your answers, do not use decimals. I want you to use the exact expression, so it will involve some square roots. Okay, so what do you know about alpha? You know that the sine of alpha is 0.75, and you know that alpha is an angle in a right triangle. So let's draw a right triangle. Here we go. Here's the right triangle. And we can put alpha either here or here. It doesn't matter. So I'm just going to put it here. Why not? Now, what does it mean that the sine of alpha is 0.75? Well, we know that the sine is a ratio of the opposite side of alpha divided by the hypotenuse, right? The opposite is this side right here, and the hypotenuse is opposite the right angle here. So it's that side. Now, 0.75 is not a ratio, but that's very easy to write it as a ratio, right? So it is 3/4. Therefore, we could assume that this side has a length of 3 and this side has a length of 4. All right, how do you find the cosine of the angle? Well, you know that the cosine of alpha is equal to the adjacent over the hypotenuse, okay? Now, you do know the hypotenuse, it's 4, but you don't know the adjacent. So let's figure it out. Let's call it x. Now, of course, we need to use the Pythagorean theorem to find x, right? So what do you have? You have that 3 squared plus x squared is equal to 4 squared, right? So what does that mean? That means that 9 plus x squared equals 16. So that means that x squared equals 16 minus 9, that's 7. And finally, we have that x equals plus or minus square root of 7. Now, of course, we are working in a right triangle, therefore, x is positive, okay? So we don't use a negative value, and we have that this side is actually, I found it, it is equal to the square root of 7. So let's write it, square root of 7. All right, we have everything now, don't we? What is the cosine of alpha? Well, the cosine of alpha is square root of 7 divided by 4. That's it. And what is the tangent of alpha? I guess I'm going to have to do this problem lower. Tangent alpha is the opposite over the adjacent, right? In SOHCAHTOA, it's TOA, opposite over adjacent. And so it is 3 over square root of 7. You may have been taught not to leave a square root at the denominator. If you want to, you can rationalize the denominator by multiplying both sides by square root 7. And you would find 3 square root of 7, 3 root 7, over, what is square root of 7 times square root of 7? It's square root of 7 squared, which is just 7, okay? So that's it. We have found the cosine and the tangent of the angle alpha. Now, we need to figure out sine square plus cosine square, so I'm going to do it here, okay? So let me figure out sine square alpha plus cosine square alpha. Forgot my square here. Cosine square alpha. Now, what is sine? 3/4. So sine square is 3/4 squared. What is cosine? Cosine, we said, was square root of 7 over 4, right? So it is square root of 7 over 4 squared, okay? So what is this? 3/4 square. How do you square a fraction? You square the numerator and you square the denominator. Plus, you do the same here. What's square root of 7 squared? It will cancel the square root, and that's just 7 over 4 squared, 16. And so what is it? It is, the denominators are the same, right? So you can add the numerators. 9 plus 7 over 16, which is 16 over 16, which is 1. That's it. We've done the first problem. Let's move on to the second. All right, same thing here. I am giving you the tan of the angle this time, and it's equal to 3. And I'm asking you to find the sine and the cosine, and to evaluate sine square of alpha plus cosine square of alpha. So, how do we do that? Well, again, you know that the tan of an angle, which is 3 here, is the opposite over the adjacent. So 3, how can you write that as a ratio? Well, there's one way to do it very easily. It is 3 over 1. Okay, we don't have to make it more complicated. So I'm going to do the same thing. I'm going to draw a right triangle right here. I'm going to place alpha right here. And I'm going to say, what's the opposite? Well, the opposite should be 3 right here, and the adjacent should be 1 right here. Okay? Now, how do you find the hypotenuse? We're going to need the hypotenuse to find the sine and the cosine, right? So let's call this hypotenuse x right here, and let's use the Pythagorean theorem. So we have that 3 squared plus 1 squared equals x squared. So that means that 9 plus 1 equals x squared. So x squared equals 10. X equals plus or minus square root of 10. Now, because we're working in a triangle, x is a length, it has to be positive. So x equals square root of 10. That's it. So now I can easily write the cosine and the sine. The cosine of alpha equals adjacent over hypotenuse. So this is square root of 10. And so it is 1 divided by square root of 10. Again, if you want to rationalize that, sometimes the question will ask you. So you got to multiply both sides by square root of 10. 10 right here. And so what is this? It is equal to square root of 10 divided by 10. Okay, square root of 10 times square root of 10 is 10. Okay, now how do you find the sine? The sine of alpha is equal to 3 divided by square root of 10. Here again, let's rationalize our denominator by multiplying both sides by the square root of 10. So it is 3 square root of 10 over 10. Okay? Okay. So now, let's do sine square alpha plus cosine square alpha. All right. What is that equal to? Well, for the sine square of alpha, I'd rather use this expression because when I'm going to square it, it's going to be very nice. Of course, you could use the other one, but it would be more cumbersome to square. So check it out. I'm going to say this is 3 over square root of 10 squared, the non-rationalized one, plus 1 over square root of 10 squared. Okay? So what is that equal to? How do you square 3 over root 10? So this is just 9 over 10 plus 1 over 10. So what is this? The denominators are the same, so it's 9 plus 1 over 10. 10 over 10, which is 1 again. Okay, we're done with the first type of problem. Let's go over the definition of an angle of elevation and an angle of depression. All right, let me quickly go over the definition. An angle of elevation, first, is an angle that the line of sight of an object above ground, above the horizontal, makes with the horizontal. You will see this is a very important aspect of the definition. And an angle of depression is an angle that the line of sight of an object below the horizontal makes with the horizontal. Let me show you the two illustrations I have right here. You'll see how it works. So right here, you see an angle of elevation. You have an object right here, which is above the horizontal. This is your horizontal. And that right here is the line of sight, is you looking at the object. That's the line of sight, okay? So the angle of elevation is the angle between the line of sight and the horizontal. Right here, that's an angle of elevation. And an angle of depression is an angle between the horizontal again and the line of sight, okay, of the object. This time the object is below the horizontal. Now you're going to have to be careful here. There's a common mistake that is made, especially, for example, if you are, for example, let's say at the top of a building right here, and you're looking down. And the problem, so here's a building right there, right? That's a building right here. And the problem is telling you, you're looking down at an object right here. And the problem is telling you the angle of depression is, let's say, 45 degree, right? It is a common mistake to put 45 right here. This is not the angle of depression, because an angle of depression is made between the line of sight right here and the horizontal, not the vertical. Here's your horizontal. The problem is that it's not given in the problem, right? Actually, if this is 45, then this one is also going to be 45. But anyway, this is where you have to put the angle of depression, okay? Let's go over some problems, and after that, you will do some problems on your own. All right, let's go over the first one. A plane descending at a constant angle of depression of 8.4 degree traveled 600 meters along its line of flight. How much altitude has it lost? Okay, so in this problem, I'm not giving you the picture, so you're going to have to read it carefully, and you will have to draw a picture that represents the situation, okay? So you have a plane. Let's put a dot right here representing the plane, okay? And it descends, right? It's descending. It goes down. A plane descending at a constant angle of depression of 8.4 degrees. So here's the line that represents the descent of the plane right here. And where's the angle of depression of 8.4 degrees? Don't forget, it's with the horizontal. So you got to draw the horizontal right here, right there. And that is 8.4 degree. Okay. And this plane travels 600 meters along its line of flight. Now, this right here is a line of flight, right? So along this line of flight, the plane travels 600 meters, let's say, here to here. Let's say it is 600 meters, right? Okay, so 600 meters, right there. Okay. How much altitude has it lost? Between what? Well, between the first position right here and the last position right there. How much altitude has it lost? Well, where's the loss of altitude? It is, if you prolong this, this is a loss of altitude, right? This right here is a loss of altitude. Altitude. So I just drew a right triangle right here, right? And I want to find this loss of altitude. So let me give it a name. Let me call that x. Now, what function are you going to use that involve this angle, this side, and this side? Well, this is the opposite and the hypotenuse, so it is the sine, okay? So you write sine of 8.4 degree equals x over 1600. Therefore, you have x equals 1600 times sine of 8.4 degrees. Of course, I multiply both sides of this equation by 1600 right here to get rid of my denominator on this side. Okay? At this point, you take your calculator and you compute this. So let's do that. So 1600 right here times the sine of 8.4. 8.4 right here. Now, before I push enter, let me make sure that I'm in degree. Yes, I am. Okay. So let's push enter. And that represents the loss of altitude, the 233 meters, 0.7. So it's about 234 meters. Okay. So I would say this is about 234 meters. Here we go. Let's go over a second type of problems. A beam bracing a wall forms an angle of 49 degrees with the ground and reaches 18 feet up the wall. Okay, so what's going on here? You got a wall right there. Okay, so you got a wall right here. Let's put the ground here. Okay, that's the ground right there. And you have a beam bracing the wall, right? So I'm going to put the beam right here. It's bracing the wall. It's leaning against the wall. Okay. And it forms an angle of 49 degrees with the ground. The beam forms an angle of 49 degrees with the ground, right? So, for 59, I'm sorry, 59 degrees. So this angle right here is 59 degrees. And the beam reaches 18 feet up the wall. So that means that this height right here is 18 feet. Okay? All right. So we can call that point A, point B, and point C if you want, right? It doesn't really matter. And of course, we're going to assume the wall is vertical with the ground that's horizontal. Therefore, we have a right angle here. If the angle, how long is a beam? How long is a beam? So we want the length of the beam right here. Okay, so here again, what's going on here? I have to find x. I know the opposite, and I want the hypotenuse. Okay, so let's do that quickly. That's going to be the sine again, right? So sine of 59 degree equals, so it's equal to 18 divided by x. Now, we want to solve for x this equation. So I'm going to multiply both sides by x right here, right? Multiply both sides by x, and you have x times the sine of 59 degree equals 18, right? That cancelled. And then I'm going to divide both sides by the sine of 59 degree right here, okay? It's a very simple equation to solve. You have to know how to do that without making a mistake. And so this is, and that's simplify the x, the sine. And so we have x equals 18 divided by sine of 59 degree. Okay, let's take the calculator. So we have 18 divided by sine of 59 right here. Oops, I didn't write 18. So 18 divided by sine of 59. Here we go. And that is about 21 what? I think it's feet, I believe. So it is about 21 feet. So the beam measure about 21 feet, okay? Now, there is a second part of the question where I'm telling you that suppose now that the angle is formed between the beam and the wall. So check it out. Let me erase that. I'm still reaching 80 feet, okay? So I guess I didn't use my letter also. Right here, the beam and the wall. So I'm talking about this angle right here, right? 59 degrees is between the beam and the wall. This is still 18 feet right here, 18 feet, okay? AC is 18, okay, right there. And I'm asking you for the length of the beam still. But this time, you're not going to use a sine because 18 is the adjacent side of 59, right? And x is the hypotenuse. So you're going to be using the cosine. So let's write it. So we have cosine 59 equals, so what's the adjacent side? It's 18 over x, right? So it is equal to 18 divided by x right here. And we have to solve for x. Now, hey guys, you may remember, but we have seen this kind of problems before where when you have like a equals b over c. I just did it previously, okay? A very quick way to solve that, just the way I did it for the sine right here, is you can exchange a and c, okay? This, if you remember that, it's very quick. So it's the same as saying, so it's exactly the same as saying c equals b over a. It just makes you go slightly faster, that's all, okay? It's not a big deal if you don't remember. Solve the way I did it in the previous problem. But right now, I'm just going to exchange these two things right there, and I'm going to say x equals 18 over the cosine of 59 degree. All right, what is this? Let's figure it out. 18 divided by cosine of 59. I forgot my cosine. Actually, I didn't forget. The computer is really a big mess. Cosine of 51, and it doesn't take all the keys. All right, so it is about 35 feet. So this time it's a longer ladder, right? The other one was 21 feet, and this time this is about 35 feet. Okay, all right. Let's do one more problem, and I'll stop this video. So last problem. Here we go. From the top of a 100 meters lighthouse, you observe a boat sailing towards shores with an angle of depression of 8 degrees. How far is the boat from the lighthouse? Now, this problem is not so clear. I really should have done the drawing. So let's put the boat right here. Here's the boat right there. Here's a boat. Okay, and it doesn't say, you know, maybe the shore is there, maybe the lighthouse is here, right? And the water is there. So it doesn't tell you at all where the lighthouse is along the shore. So I have to be clearer than that. Let's suppose the lighthouse is right there on the edge of the water. Okay, just to make it a bit easier. Right here, that's a lighthouse. It's 100 meters tall, 100 meters tall right here. And you're right there, and you observe a boat that's sailing towards the lighthouse, right? And the angle, the boat's right here, and this is the sea, right there, right there. And the angle of depression is 8 degrees. Now be careful where you're gonna put this baby here, okay? The angle of depression goes right here, okay? 8 degrees, right there. Okay, so what's the question? The question is, how far is the boat from the lighthouse? So of course I want this, that's a right angle, I want this side right here, okay? Now, if this is 8 degrees right here, what's that? Well, you got a right angle right there, right? So this is 8 degrees, so what are you missing to make a right angle? You're missing 82 degrees, okay? A right angle is 90 degrees, so that's what you're missing. So now, what do you have? You have this side, this angle, and you want this side right here. So this is the adjacent, and that's the hypotenuse. So you're playing with the tan of the angle. Okay, you're playing with the tan of the angle. So we can write tan of 82 degrees equals x divided by 100 meters. And you multiply both sides by 100, and you get x equals tan of 82 degrees times 100 meters. So what is that? Tan of 82 times 100, it is equal to 711.5, so 712, let's say. I'm running to the units, everything. meters. The boat is about 712 meters away from the shore, from the lighthouse. Thank you for watching.